for the definition inequality is that if you have any real numbers, A and B, if A is greater than B, if and only if there's a positive C. Sorry, I wrote that backwards. Oh, no, I didn't. Sorry, I wrote my example backwards. Okay. So A is greater than B only if there's a number C, so that if you add B and C together, it's equal to A. So for example, if 5 equals 2 plus 3, that means that 5 is greater than 2 and 5 is greater than 3. So what we're saying is A is only greater than B if you can add something to B and have it equal A. So then we have some properties of inequalities. If A is less than B, if A is less than, and we're going to compare them. A is less than B, A is equal to B, or A is greater than B. And it's going to be only one of these things, right? You can't be equal to B and less than B.
Greater than, you can't be greater than and equal, or less than?
You can be greater than or equal. When you have the less than and equal sign, it's actually less than or equal. You can only be one or the other. You can't be both at the same time. You can't be less than and equal. Okay, transitive property, there's two versions. The first one, if A is less than B and B is less than C, that makes A less than C, right? Because if A is smaller than B and B is smaller than C, then A has to be smaller than C. And vice versa. If A is greater than B and B is greater than C, then A is going to be greater than C.
How would that work?
Well, this is just a property. It's not exactly an equation, but I'm saying, like, if I have some number A, like say it's 5, and I say B is 6, no, not 6, 3. So 5 and 3, and then I tell you that B is greater than C. What do you know about C? It's going to have to be less than 5. 2, 1, negative something. We just know that it would be less than the original 5. The addition properties, if A is less than B and I add something to A, as long as I add it to both sides, it'll stay less than. Same thing as if A is greater than B. If I add the same thing to both sides, it stays greater than, as long as it's the same number on both sides. And then we have the same with subtraction. If A is less than B, then if I subtract the same number from both sides, it still stays less than. Or if A is greater than B, I can subtract the same number and it stays greater than. For the exterior angle theorem?
Yeah.
It's like the same thing as algebra.
Right. Angle 3 is equal to 1 and 2 added together. Okay, well, if angle 3 is equal to 1 plus 2, then that leads us to 5, 8, which is the exterior angle inequality, which states that the measure of an exterior angle of a triangle is greater than the measures of either corresponding, I'm spelling corresponding wrong. Remote interior angles. Okay, so basically what this says is that the measure of angle 3 is going to be greater than the measure of angle 1, and the measure of angle 3 is going to be greater than the measure of angle 2. Yeah, if you think about it, it makes sense, because if angle 3 equals 1 plus 2, then 3 has to be bigger than 1 and it has to be bigger than 2. Logically speaking. This brings us to what kind of problems you're going to need to be doing. So we look at the exterior angle inequality theorem and we list all the angles that satisfy the condition that measure less than angle 7. Well, okay, angle 7 is here, right?
I see all the angles of lessons to angle 7 except L.
We've got this triangle, that angle 7 is an exterior angle 2. So these are the two remote interior angles in that triangle. So we can list those, angle 5 and angle 4. We also have the big triangle, see that? And angle 7 is an exterior angle to the big triangle as well, triangle JKL. So it would be exterior to angle, or sorry, greater than angle 1 and then greater than this whole angle, which is 2 plus 4. But we already knew it was greater than 4. So it's greater than angle 1 and greater than angle 2. Okay, for angle 6, we want greater than angle 6. Well, angle 6 is a remote interior angle for this triangle, huh?
That angle is 190?
No, we don't know what 6 is by itself.
Oh, okay.
But we know that angle 6 inside the small triangle is a remote interior angle to angle 8. So we can put angle 8 down. And then if you look, it's also, if you take into consideration 6 and 4, it's remote interior angle to angle 3. Does that make sense? So if I look at 6 and 4 together, that gives me angle 3. If I look at 6 and 5 together, that gives me angle 8. Okay, and we want to look at the angles that measure less than angle 1. So we look at angle 1, that's right here. Okay, the remote interior angles to angle 1 are this angle and this angle. Well, this big angle is made up of 2 angles, and so is this other one. So that's, we know that these 4 angles will be smaller than angle 1 because they make up the 2 remote interior angles. If we look at angle 8, angle 8 is a remote interior angle with angles 5 and 6 to angle 2. That's the exterior angle for 8. So when we say its measures greater than, we know this exterior angle is greater than angle 8, so that's just going to be angle 2. If there was another exterior angle over here, it would also be greater than. You know, if I stuck some other exterior angle out here, but we don't have another one, so it's just angle 2.
He doesn't understand this.
Side inequalities.
So like,
And what we have is, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure. So if we have like the longest side, it's going to be across from the largest angle. And likewise, if we have the smallest side, it'll be across from the smallest angle. Okay. So just to give you a concrete example. If I have some triangle and I label it, you know, ABC, and I tell you that and side AB is 9 and side BC is 7, well, I know that means that AB is going to be greater than BC, right? Because 9 is greater than 7. Well, if I look at the angles across from these two numbers, that lets me know that angle C is going to be greater than angle A, because angle C is across from the side that's larger, so it's going to be larger than the other angle that's across from the side that's shorter. And then that kind of goes the opposite direction as well. Sorry, let me make that a little bigger. If I know one angle, let's say, is 45 degrees, and I know another angle is 110 degrees, well, so I know for a fact that angle K is bigger than angle J, right? Well, that would mean that then if I do this, across from K is JL, and that's going to be larger than across from J, which is KL. Largest. So first we say, okay, well, what's the smallest side?
you don't have that?
Yeah, you do. It's on the back. Okay, so we first find the smallest side, right? Smallest.
Yes.
And that is across from, wow, that's a terrible straight line. Okay, hold on. I'm having a problem with my lines. Okay, better. The smallest side is across from the smallest angle, so the smallest angle is going to be angle Q. Okay. And then we have the largest. And the largest is going to be across from angle P. So here's our middle, and that's angle R. So it goes Q, R, P. Oops, angle P. From smallest to largest. So in the middle is across from angle B. So to put them in order, it's going to go angle C, angle B, and then angle A. So that's from smallest to largest. Up ahead of me. All right, so in order to figure out least to greatest, I first need to know how much that is.
You just gotta add 2 and minus it.
Yeah. So we know that a triangle has 180 degrees. So what I'm going to do is I'm going to do 45 plus 56. It's 101. And then I'm going to do 180 minus 101. 79. So angle F is 79 degrees.
If there's one angle out, you can try and find out the other ones.
So this is my largest angle.
Here.
So it's going to point to my largest side. Yeah, greatest. And then the smallest or least angle is 45. And it's going to point to my smallest or least side. So to put them in order, I'm going to have side FH. And then the next one will be GF, because that's across from this middle angle. And then the next one will be GH. And I'm listing the sides in order from least to greatest. FG, FH, yeah. So when you're naming the sides, you use the 2 letters unless the side has been named something specifically. You know, if like this side was called Q, you could just say Q, but it's not. Indirect reasoning is when you assume something's false and then show that it's a contradiction so that whatever you were saying to begin with would have to be true. Just a very, very simplistic indirect reasoning would be if you tell your son if you need to eat all your dinner or you're not going to have dessert, and he doesn't believe you. He says, and I'm like, okay, well then why don't you go ahead and not eat your dinner and see what happens.
Oh, I see.
And then they don't eat their dinner, and then when they go, okay, dessert, you're like, yeah, no dessert. See, that's what happens. So it's like a contradiction.
Can I make another example like that?
Sure.
Basically, like when your son, really? When you always eat dinner and you have dessert.
Need to make sure he has a marathon to run.
What are you going to do about Halloween?
Is we're going to assume that what we try to prove is false. Okay, let's say I want to prove that the sky is blue. Then my first statement is the sky is not blue. So I start with making it false.
But some people also think that the sky is not blue. Which sounds weird.
I'm going to prove that rocks sink. So in order to prove that rocks sink, I'm going to assume that what I'm trying to prove is false, so I'm going to say rocks float. And then I'm going to show that the assumption is logically impossible by taking a bunch of different rocks and maybe a bunch of different kind of rocks and trying to make them all float. Well, when none of them float, I have proven that my assumption was false, that rocks don't float. Therefore, my original conclusion that I was trying to prove is true. Rocks sink. Proof. Okay, so step 1 is we're going to identify the conclusion we're asked to prove, and then we make the assumption that it is false by assuming the opposite is true. So first thing we have to do is we have to make an opposite statement. Then we use logical reasoning to show that that statement we came up with leads to a contradiction. Once that does not have 2 S's in it, sorry. Once that leads to a contradiction, our assumption is false. That means the opposite of it must be true, which was the original thing we were trying to prove. So, to start out with, we need to come up with assumptions necessary to start the indirect proof. So if I'm saying that angle ABC is congruent to angle XYZ, my opposite statement is that they're not congruent. Okay. If I say if 6 is a factor of n, then 2 is a factor of n, my opposite statement is going to be 2 is not a factor of n. If I'm trying to prove angle 3 is an obtuse angle, I say angle 3 is not obtuse. So I'm always just going to go with the opposite of whatever I'm trying to prove. So what we are given is negative 3x plus 4 is greater than 16. That's our given statement. And we're trying to prove x is less than negative 4. So we're going to use an indirect proof. So in order to do that, the first thing we're going to do is we're going to assume
What does it say?
x is greater than or equal to negative 4.
Is that plus or
Negative
plus?
3x plus 4. It's right
Okay.
here.
Oh, ooh.
That means it has to be greater than or equal to. So then we're going to make a table. So if I pick random values that are greater than negative 4 or equal to negative 4 and plug them in just to see what happens. This is my logical reasoning.
Oh, I did this before.
So if I say, well, negative 2 is greater than negative 4, so I'm going to plug the negative 2 in, and I'm going to get 6 plus 4, that's 10. 10 is not greater than 16. I could plug in 0, that's greater than negative 4.
So before.
And before. I might plug in negative 3. That's going to give me 9 plus 4, that's going to give me 13. If I plug in negative 4, because I did say or equal to, so I need to test that one as well, I'm going to get exactly 16. I don't want exactly 16. I want greater than 16.
What about negative 5 then? It'll be 15. It'll be 19.
Negative 4 is not, or negative 5 is not greater than negative 4.
Oh, I see.
I'm using my assumption, which is that, because I'm trying to prove that x is less than negative 4. So I'm trying to, yeah, so therefore our assumption is false. Therefore, x is less than negative 4. So that's how we were able to prove it. We said, well, if we say that x is greater than negative 4 and we pick all these values and we test them, then it's not, doesn't work. Therefore, it's false. So that means what we were trying to prove is true, because the opposite of it was false. Let's break it down, okay? So Javier asked his friend Christopher the cost of his meal and his date's meal when he went to dinner for prom. Useless information. Okay, no numbers in there, right? Okay, Christopher could not remember the individual costs, but he did remember that the total bill, not including the tip, was over $60. Okay, so him and his date was over $60. We're going to use indirect reasoning to show that at least one of the meals was more than 30. Okay, so if I say that, okay, hold on, let me see this. I need to change this. We're going to let x equal Christopher. Or rather, Christopher's meal. And y equal his date. Okay. So what we've been told, what we're given, is that when they both ate, it was more than $60. And we want to use indirect reasoning to show that at least one of the meals was more than $30. So I'm going to try to prove that x is greater than 30 or y is greater than 30. Okay, so I know x plus y was more than 60, and I want to prove that either x was less than or greater than 30 or y was greater than 30. So my assumption, my opposite statement, I'll put that in red because it's opposite. I'm going to assume x is less than or equal to 30 and y is less than or equal to 30. This is my opposite statement. Okay. So here's my proof.
Is it going to be on a test or something on it?
They're assuming that x and y are both less than or equal to 30, right? Well, that would mean x plus y is less than or equal to 30 plus 30, which means that x plus y is less than or equal to 60. But that contradicts what we were trying to prove, our given statement. Our given statement was that x plus y is greater than 60. So it's a contradiction. It can't be less than or equal to 60 and also greater than 60. It's one or the other. So therefore, x has to be greater than 30 or y has to be greater than 30 or both. First of all, do you guys remember that an odd number is of the form 2k plus 1?
I remember that, but I just ain't forgetting.
All right, so we're going to write an indirect proof to show that this x plus 2 is even, or if this is true, then this is true. So we're given, the if is always the given part. So we're given x plus 2 is an even integer. And we want to prove x is even. Also an integer. Wow, I can't write today. All right, so our opposite statement. We're going to assume x is odd. Okay, so we're going to assume x is odd. Okay, if x is odd, x has to equal 2k plus 1 for some integer k. I don't know what k equals. I just know that if x is odd, it's of the form 2k plus 1. Okay. Well, x plus 2 would then equal 2k plus 1 plus 2, right? Because x is 2k plus 1. And then we added plus 2 to it. And I'll just write this down. That's by substitution. Just so you know where I'm coming from, I substituted this 2k plus 1 in for that x. Well, addition is commutative. So I can switch their order. I can move the 2 and the 1. And then I can factor out a 2. Right? I took a 2 out of 2k plus 2. I factored it out. I can divide both of these by 2. Right? And I could take the 2 out, and then 2k divided by 2 is just k, and 2 divided by 2 is 1. Not yet. No, I'm trying to prove that x is odd. Or sorry, I'm trying to prove x is even, and I'm assuming x is odd. But I've been told x plus 2 is even.
So you just divided the 2 and the 2?
I just divided the 2 out of here, yeah. So now, if I say, I need some other letter. What letter you guys want me to use?
What about J?
All right. Let J equal K plus 1.
Is this an example you write right now?
Does that say, does it say, the one right above J, does it say, it says X
Plus 2. It's
equals
2 times the parenthesis
yeah,
K plus 1 parenthesis
plus
plus 1. And so now what have I done is I've taken this K plus 1, right? And I said J is the same thing as K plus 1.
Where did that other one come from on the end?
It was plus 1 plus 2,
Uh-huh.
and I flipped them and made it plus 2 plus 1. Because I'm allowed to do that with addition. I can change the order. So I just took this 1 and the 2 and I switched their places.
Yeah, same thing, right?
Yeah.
2 divided by 2 is 1.
Well, why would you switch it?
So that I could divide by 2.
So where did this 2 come?
This 2 here came out of here.
Okay, but you divided those.
I divided each of them by 2, so I factored it out. So like, okay, so if I had 6 plus 4, right?
Yeah.
And I didn't add those together for some reason, I could factor out a 2 and it would become 3 plus 2. So 6 plus 4 is 10, right? This is 5. 2 times 5 is also 10. So I can pull things out by division and it doesn't change anything.
Oh, so all the numbers are still there.
All the numbers are still here. I've just
You just made
pulled it out,
you
made it
just
look
made
different.
simpler.
Yeah. Yeah, I made it look different.
So you really didn't do anything. You just.
Not really, no. I just moved things around and changed it a little bit.
But we could do it. Technically, we could do it the first way, right?
Here?
Yeah.
Well, no, because here's what I'm trying to do. I've been told that x plus 2 is even,
Yeah.
and that leads me to x being even. Well, I'm going to assume x is odd. And I'm going to now use that x is odd to show that that would make x plus 2 also odd. And then that's a contradiction. I'm trying to contradict things.
What is the point of moving?
To get to here. To make this right here. I'm trying to make this. Well, actually what I was trying to do is I was trying to make this look like that. Because now anything in the form of 2k to j to x to y, whatever, plus 1 is odd. And I started out with x plus 2 equaling this. So if x plus 2 is equal to an odd number, I already know x plus 2 is even. That's my contradiction. So this is contradiction. That contradicts. X plus 2 is even. So therefore, x is even. This whole thing was just so I could prove that I had a contradiction.
I don't know. I guess it just seems.
So I'm going to draw a picture.
You got nothing new?
No? Draw some triangle with an exterior angle. Label it. Okay. All right, so what we're given, if an angle is an exterior angle of a triangle, we're going to prove that its measure is greater than the measure of either of its corresponding remote interior angles. So all we're given is an angle is an exterior angle. That's what we're given. Okay, now I labeled it, so I'm going to say angle 4. Okay. Sorry, not in, it's of. All right, so I want to prove that the measure is greater than either of its corresponding remote interior angles. So I'm trying to prove that the measure of angle 4 is greater than the measure of angle 1. And the measure of angle 4 is greater than the measure of angle 2. Okay.
Indian looked ahead of us.
Okay. So we got less than, right? Well, if we know that angle 4 is an exterior angle, by the exterior angle theorem, right? That tells me that 4 is equal to 1 plus 2. Well, if this is the case, I'm saying that angle 4 is less than something that is added up to make it. That doesn't work unless you have negative numbers, right? Okay, all angles are positive. So it's impossible for angle 4 to be less than angle 1 and then angle 1 add up to something with something else to equal angle 4. That's not possible. Because that would mean that angle 2 has to be some negative number, and that's not a possibility. So this is a contradiction. Okay, so I know that the measure of angle 4 is not less than the measure of angle 1. Okay, so I've proven part of that. I got rid of case 1. All right, so if this is true, well, I know that angle 4 is equal to angle 1 plus angle 2, because again, we have that exterior angle theorem. The THM is my little shortcut for theorem when I run out of space. Is that confusing? Well, if I use substitution, that means angle 4 is equal to angle 4 plus angle 2, right? Because if angle 4 and angle 1 are the same. And then I could come in here and I could subtract angle 4 from both sides. So this was substitution. Which would mean 0 is equal to the measure of angle 2, and that was from the subtraction. And can an angle equal 0? No. So the measure of angle 2, it's no way it equals 0. So I have a contradiction. So then I know that the measure of angle 4 is not equal to the measure of angle 1. Sorry, measure of angle 1. Okay. And if it's true for angle 1, the same steps would be true for angle 2, so we don't have to do angle 2 again. So then that means the measure of angle 4 has to be greater than the measure of angle 1, and the measure of angle 4 has to be greater than the measure of angle 2. Because we contradicted both options for it to not be greater.